In this video, we'll explain rescale factor, a property of fidget stepper controllers. Setting a rescale factor allows you to change the units of position, velocity, and acceleration from the default unit of 16th steps to something more intuitive like rotations or degrees. When we first open the fidget control panel, these units are all in 16th steps. A velocity of 20,000 steps per second is difficult to conceptualize, and the position moved will vary depending on your motor's specifications. Rescale factor lets us easily change to something useful, like degrees. In order to calculate the rescale factor we require the step angle and gear ratio of the motor. Both can be found in the motor's specification table. By entering the motor step angle and the gearbox reduction ratio, we can quickly set a rescale value. Now we can enter a target in degrees, and the motor will move accordingly. Here's how the rescale calculation is done behind the scenes. Start with the desired unit, degrees. The step angle of the motor is 1.8 degrees, and there are 16 microsteps sent by the controller to form one step. Then, divide by the gear ratio of the motor's gearbox. Intermediate units cancel out, leaving us with degrees per microstep. The same process could be used to calculate rotations, radians, or any other unit that's helpful for your application. In run mode, you can use the same technique to rescale velocity in RPM. Sometimes a motor is used to drive a more complex mechanical system, and a rescale factor can help simplify your units in this case too. Here we have a linear motion assembly, driven by a stepper motor. The motor drives a pulley connected to a ball screw that converts the rotation into linear movement. We can set a rescale factor that reflects the movement of the platform in millimeters. In situations like these, the rescale factor must be calculated manually. Start at the platform and work your way back to the controller. The ball screw has a lead of 5 mm, so it will move 5 mm with one rotation of the screw. Next, it connects to a 34-tooth pulley joined to a 12-tooth pulley, so we divide by that ratio. That pulley connects to the stepper's output shaft, whose gearbox has a 5.18:1 ratio. We'll use the fractional form for better precision. There are 360 degrees in a rotation, and the step angle is 1.8 degrees. Lastly, the controller outputs position in 16th steps, so we divide by 16. We can set this rescale factor, and now the position is in millimeters. A minus sign is placed in front of the rescale value to make a positive position result in movement to the right. This concludes the overview of the rescale factor property. For further reading, see the API guide for your motor controller. Links are available in the description of this video.